Okay, so in this class we'll do this test 6.2 questions 7, 8, 9 and 10. Okay, this is on page 135 of your textbook, so go there. Question number 7, let's start with that. B7, sorry. Question B7 we'll find on page 135. So using theorem 6.2, sorry 6.1, prove that the line drawn through the midpoint of one side of a triangle parallel to the another side bisects the third side. So this question is basically saying a triangle is given to us. Let us assume it's A, B and C. So a line is drawn through the midpoint of one side. So let us say we took the midpoint of the first side AB here. P means this AP will be equal to PB. That is the meaning of P is the midpoint of AB. That line touches the third side and is parallel to the second side, right? And question is saying that line will go and cut the third side SC equally, means bisect. Okay, so here given to us is, according to the question, in this triangle ABC, P is the midpoint of the side AB and PQ parallel to the second side BC. This PQ is parallel to second side BC. P bisects is the midpoint of first side AB. So that is what it is saying. In other words, P is midpoint of AB means AP equal to PB. AP equal to PB. So middle point of AB means this and this will be equal, right? So next here we have to prove that this line which starts from the midpoint of first side parallel to the second side BC will bisect the third side. The question is saying bisect the third side means we have to prove AQ is equal to QC, meaning Q is the midpoint of SC also. That's what we have to prove. Let's start with the proof. Proof is here. Let us say here AP is equal to PB. We know this is because it is given in the question that P is the midpoint of AB. So AP equal to PB given. So we know that any number can be multiplied by 1. So here we can just put into 1, right? So AP divided by, you shift this, then it will go to denominator. So AP by PB equal to 1. Let us keep this as equation 1. Then we can write here, next one here, in triangle ABC, the big one, PQ is parallel to BC is given in the question. It's already given. So if a line is parallel to one side of the triangle, we know that by basic proportionality theorem, that line AP divided by PB will be equal to AQ by QC. Since using basic proportionality theorem. So this is the reason. If a line is parallel to one side of a triangle, it will divide the other two sides AB and SC in same ratio. So that is the theorem, basic proportionality theorem. That implies, but AP by PB we have got here 1. So we can replace this one by 1 is equal to AQ by QC, and we can write here, since using equation number 1. So that way we can get here QC in the 1 will go up equal to AQ. Hence proved. See here, QC equal to AQ. We have to prove that this line bisects the third side AC means AQ equal to QC. So here AQ equal to QC. Proved, right? We'll go to the next one, 7, B 8. Let me read the question for us. Using Theorem 6.2, that means Converse. Now we have used Theorem 6.1 in question 7. That is basic proportionality theorem, and Theorem 6.2 on your textbook is Converse. Okay, so we'll use the converse of basic proportionality theorem this time. Prove that the line joining the midpoint of any two sides of a triangle is parallel to the third side. So this question is basically saying there's a triangle. Let us say A, B, and C. P is the midpoint of AB, and let us say Q is the midpoint of SC. That means these 2 points are the midpoints of this side and this side, meaning this AP equal to PB and AQ equal to QC. So if you join that, question is saying prove that that line is parallel to the third side BC. So given to us here in triangle ABC, P and Q are the midpoints of the side AB and the side SC respectively. So in other words, that means here P is the midpoint of AB means AP equal to PB. Q is the midpoint of SC means AQ equal to QC, right? Now we have to prove here that this line joining these two midpoints P and Q, this PQ, is parallel to the third side BC. That's what it means. So in order to prove this, let us take here proof. We have here AP equal to PB since it is given to us. So we can write here given to us. So we can multiply by 1, and so we can write like this: AP by PB equal to 1, equation 1, let us say. Similarly, you take the next one, AQ equal to QC into 1 as it is given. So we can write here AQ by QC, AQ by QC equal to 1. And as we proceed and do, that implies AQ by QC will be equal to 1, here can be replaced by this one, AP by PB, and we write here since using equation number 1. Okay, now I can put this one as equation number 2 and write finally here in the triangle ABC. Now we got this one, AQ divided by QC equal to AP divided by PB since using equation number 2, right? So in other words, what does this tell you? AQ by QC equal to AP by PB means this line PQ divides this side AC, and then here AQ by AC QC, and then AP by PB, this one P divides this side AB in the same or equal ratio. So this AQ by QC equal to AP by PB means this line touches this AB and SC, dividing them into small segments of equal ratio or in the same ratio. So therefore we know that such a line will be parallel to the third side Alright, we learned this theorem in the first class, and this theorem is called Converse of basic proportionality theorem. So by converse of basic proportionality theorem in theorem 6.2, we have proved that this line is parallel to the third side, right? So that is question number 8. Now let's go to 9. Let's do slowly. It's quite easy, okay? Just systematically we do it. Now let me read question number B9, page 135, okay? I hope you have opened your textbook to that page. ABCD is a trapezium in which AB parallel to DC. So let's draw that trapezium. ABCD in which AB is parallel to DC. These two lines are parallel. Trapezium is a four-sided figure, quadrilateral, in which a pair of opposite sides must be parallel. So this is trapezium because one pair of opposite sides, AB and DC, opposite sides are parallel. Okay. Then diagonals intersect at point O. So diagonal means the straight line joining any two non-consecutive vertices. Now the sharp points here are called vertices. So this vertex A and D are nearby is consecutive, but A and C are far away, so that's called non-consecutive. You join, that's the diagonal. Here also D is non-consecutive to B vertex. So joining these two vertices D and B, which are non-consecutive, is called diagonal, and they intersect at O. So given to us here, as it is in the question, ABCD is a trapezium in which we can write in short as TRAP, okay? In which the side AB is parallel to DC and its diagonals, okay? Its diagonals intersect each other at the point. Oh, that's what it says. Now we have to show means to prove only. To prove, we have here, look into your text, AO by BO. AO by BO equal to CO by DO. This is what we have to prove. In order to prove this, let us do a construction here. Let us say we draw a line EO parallel to, here EO is parallel to DC, let us say. So let us do the construction. Construction is draw OE parallel to DC. Okay, OE parallel DC, if you want, intersecting the side AD at the point E. So this EO touch AD at E and is parallel to DC. So let us prove now, start. Proof is here. Okay, no, this one, we need this one, sorry. So construction, continue, and then let it draw EF, sorry, slight correction, EF parallel to DC. Okay, EF, okay, just do like this, draw EF through, I thought it's the converse, sorry, through O, okay, through O, such that EF is parallel to DC. So this EF parallel to DC. So let us do that now. To prove, okay, so AO by CO equal to AE by So we take this one, then this one, then we take that. Okay, so let us take here triangle ADB. Let us take that one first. ADB. We know by construction EF is parallel to DC as given in the construction. Since construction, okay, so EF parallel to DC, that is, in other words, EO is parallel to DC. EO parallel to DC. Then go on to do, if a line is parallel to one side in this triangle, it will divide the other two sides. AE by ED will be equal to AO by OC, since using basic proportionality theorem, by using basic proportionality theorem, right? So let us keep this one, AE by ED is equal to AO by OC. Let us keep this one as equation number 1. Then let us take here the other triangle in triangle. Okay, ADB. We took ADB now. Let us take we took ADC here. See? No, this is ADC, sorry. In ADC, in triangle ADC, ADC. Okay. Now let us take this triangle we have already taken. Now let us take this one, ADB. Okay. So in this triangle, we know that, let us do this one. EF is parallel to DC is given by construction. We know this one. Look here. EF parallel to DC construction. Now here, this AB is also parallel to DC as it is given. You can see here very clearly. AB parallel to DC. So EF parallel to DC, AB also parallel to DC. The same line DC means those two lines also will be parallel to each other. We know this one from our lower classes also. See here, EF parallel to DC, AB also parallel to DC. So both of these are parallel. The same line means they themselves will be parallel to each other. That's what we mean. So in other words, we can cut EO parallel to AB because EO is a part of the full EF. So in triangle ADB, EO parallel to AB means ADB, this triangle. We can write here, therefore, AE here, this line parallel to AB in this triangle means we can write AE by ED if you write, will be equal to, you go down, went down first, so here also down, BO by OD. Since the same reason as above, that is converse of, basic proportionality theorem. So now that gives you here AE by ED is same as this one in equation number 1. So replace that one by this one, we can do that. AO by OC will be equal to BO by OD, since using equation number 1. Now here, as you continue to do, you can change these things to these terms here, AO by BO. So AO, CO, so OC you can write as CO, same thing. BO is okay. OD is written as DO, so we can just change it to this order if you want. Otherwise it's also okay. Now you cross multiply. Then AO will multiply up and down. BO will be equal to, after equal sign, CO into BO. So we will get like that. We just continue to do. Then here we want this one, AO by BO. So let us not touch this one, AO. In order to get this one, AO by BO, then we shift this one this side to this one. So BO We didn't shift yet CO, so just keep that one. Then we have done this AO by BO. We didn't touch this, so shift this one means it will go down. So DO will go down. If we compare that to this one, it's exactly the same. AO by BO equal to CO by DO. So this is proved, right? Now let us go to the last question, B10. B10. Here B10. Diagonals of a quadrilateral ABCD intersect each other at point O, such that AO by BO equal to CO by DO. Show that ABCD is a trapezium. So quadrilateral means four-sided figure. A, B, C, D, and the diagonals means this line and this line intersect at O. Let's write down what is given to us. Given is the diagonals of a quadrilateral. Okay, diagonals of a quadrilateral ABCD intersect each other at the point O, such that AO by BO is equal to CO by DO. Okay, we'll have to show that to prove that. Last sentence, you see, ABCD is a trapezium. ABCD is a trapezium. Let's do construction. Here the construction will be quite simple. Through this O, you just draw a line. So draw OE, let us say parallel to DC. Parallel to DC, intersecting AD at E. So this line is parallel to DC and cuts AD at E. That's our construction. To keep it simple, proof. Now look here. In the triangle ADC, let us take this one here. ADC. This one, AO is parallel to DC since by construction. So if a line is parallel to one side, the ratios here, AO by CO. Okay. So here AE by ED will be equal to AO by CO. AO by CO, and all of us know this using basic proportionality theorem, right? By now we are very accustomed with the basic proportionality theorem, which says a line parallel to one side of a triangle divides the other two sides AD and AC in the equal ratio, means AE by ED will be equal to AO by CO. Right, so let us continue to do. Now here, let's keep this one as equation 1, and let us write here AO by BO equal to CO by DO, because it is given to us in the question itself, you see here. Now let us do this and try to bring this one in this format, AO by CO. In order for that, you can just cross multiply up and down, that means AO into DO. After that, equal sign and down and up, so BO into CO. Now we're trying to get into this format, AO by CO. So don't touch this, AO by CO, bring then don't touch this, then shift this one, we'll get like that, right? So which is exactly this one, AO by CO. Now let us write here that implies AO by CO, which is the same as this in equation 1, can be replaced therefore by this one, AE by ED is equal to BO by DO. And we can write here since using equation number 1. So let us put this one as equation 2. Then here, let us take this triangle now, the other reverse, A, DB. We've taken this first to get this. Now let us take this, we have taken this, now let's take this, ADB. Right, this one, AE by ED is equal to BO by DO, since using equation number 2, okay, equation number 2. Now here, in this triangle, AE by ED equal to BO by DO means this line EO, in other words, EO divides this side here AD and this side here BD in the same ratio. That's the meaning. AE by ED equal to BO by DO means EO is dividing AD and BD in equal ratio. Right, so if a line divides any two sides of a triangle in two sides AD and BD of this triangle ADB in same ratio like this, then we know therefore that line EO becomes parallel to the third side AB. So since this divides this and this in this triangle, it will be parallel to the third side AB. And we know the reason is since using converse of basic proportionality theorem. Converse of basic proportionality theorem. So EO parallel to AB, we got that just now. But here, okay, so EO parallel to AB. But we also know here that EO is already parallel to DC, since by construction, as you can see here, EO parallel to DC. Combined with what we got just now, EO parallel to AB, we realize AB and DC are parallel to the same line, so they will be parallel to each other. If a line, what we mean to say is if a line, same line is parallel to two different lines, those two lines will be parallel to that also. So those two lines will be parallel to each other also. So AB parallel to DC. That is, now if we can prove that AB and DC are parallel, a pair of opposite sides are parallel in a quadrilateral four-side figure, then that is a trapezium. So therefore ABCD is a trapezium. So our answer, ABCD is a trapezium, because we have managed to prove that AB parallel to DC, which is a pair of opposite sides of this quadrilateral ABCD. Okay, this concludes the part. You can go and give the test now.